All right, hello everyone. I'm going to be showing you what action potentials are. We went over it a little bit in class, but I did want to clarify to make sure everybody still remembers, and I'm going a little bit more in depth just so that everybody can understand the activity that is also assigned to this lesson. We'll just keep going. So this is a neuron. You recognize this. We've seen this before. These are the dendrites. This is the cell body, the axon, and the axon terminal. Neurons that look like this will receive information from the left side. It will travel through the axon and then leave to go to the next neuron over here. And it's just a cycle like that. So I want to take a look at what's happening inside of the cell body. Um, Inside of here, we have a bunch of receptors along the edges. And when those receptors get neurotransmitters like serotonin or dopamine or norepinephrine, there's a bunch of different ones, then that sends a signal to the neuron that they need to start letting in positive ions. So it looks like this inside. After all of those after all of those channels start letting in positive ions. And just as a refresher, ions are positively charged or negatively charged particles. Usually it means that they are missing or they have one extra electron. So that's where all of that comes to be important, but you'll talk about that more in chemistry. But all you need to know of what's happening in here is it's becoming increasingly positive, and this is whenever we're trying to get up to threshold, which is at negative 55-ish, from negative 70. That's what's happening here. That's how we get up, is all of these positive ions start to rush in. So we have that. Then we need to talk about what's happening right here, right before the axon starts. So these are channels, and they let in those ions. So on the outside, there are more positive ions than there are negative ions. Remember that even though we let in positive ions here, the overall membrane potential voltage is still negative 55. So it's still more negative inside than it is outside. So we need to fix that. These are called voltage gated sodium channels. You don't really need to know anything about them except that whenever the body reaches a certain voltage, these will open up and they let in only sodium, so Na plus, so that's a positive ion, only sodium ions. That's very important. We'll get back to that in a little bit. So those sodium ions are out here in space and then they pass through these channels. When they do that, our membrane potential can go up to positive 30 millivolts. And what you probably remember is that positive 30 millivolts is our action potential. So that's whenever you get the here and whoop, and it goes straight up and then back down. That 30 millivolts is what happens when all of these sodium ions rush in. But that would never go back down if nothing happened. So what happens is we also have these voltage gated potassium channels. And what I didn't tell you before is you actually already have positive potassium ions inside the cell. They already exist inside. So what happens when we get up to this positive 30 millivolts is these sodium channels also get a message that it's time to close production. So they have this little ball and chain looking thing that will actually not necessarily close it, they just inactivate it, which isn't the same thing. You don't need to know the difference, but basically there's a second process that will tell the sodium channel, hey, you need to inactivate. You cannot let any more sodium in. And then to get that membrane potential back down, so these stop working. To get that membrane potential back down, we need to let out all of these potassium ions. Remember that sodium only deals with sodium, potassium channels only deal with potassium. So none of these sodium ions can leave through the potassium channel. But while these are not active, these ones still are. So sodium channels are still working even when, or potassium channels are still working even when sodium channels are not. So we have, or let me go back, make sure it's understood. So these will end up leaving and the membrane potential will go down. So it'll go back down to your negative 70. But it's important to note that this is not only happening here, but also here, and also here, here, and here. So in order to get this signal all the way through, we need to make sure that we are kind of fixing anything that's lost here, 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 and here. Those positive ions will actually just travel down the axon through these parts. That's why these are good insulators, so we're not losing a whole lot of positive charge. And there's also no voltage channels on the axon where these myelinated sheaths are. It's only at the nodes of Ranvier. So if you remember that from before, that's where this comes to be important, that you know what the node of Ranvier is, because that's where there are more of these channels to make sure that we're maintaining the correct balance. And these are the myelin sheaths. So this is our big insulators, really important. There is no channels, no channels. I repeat, no channels on this part of the axon because they are covered with a bunch of different cells called Schwann cells that make sure that, kind of like a rubber covers electrical cords, to make sure that none of that electricity leaves. Because if we do, the message from here would not get to here. It's like if you've ever played telephone and somebody here didn't really hear the correct thing, and now this person doesn't know, now this person doesn't know, and this person, now this person thinks you said that you're going to go take your dog for a walk rather than you're going to go get ice cream from the ice cream shop. So really important that this message is here. So just as a refresher, to connect this to something you have seen, this is our action potential graph. As you can see, we start at negative 70. That's when we're super, super negative over here. And then eventually some positive ions come in. And whenever that happens, they let them all in. And then they need to say, stop! Stop letting everyone in. And that's when those sodium channels will close. And this is when the potassium channels are still open, because we're starting to let out those positive ions. Because remember, potassium goes out, not comes in like sodium. So that's why potassium channels being open is such a big deal, because they are actually leaving instead of coming in. Because we want our cell to be positive. So if we get rid of positive ions, then we're making it more negative. And then it will overcorrect, and it'll happen again and again and again. But you can actually take a reading of this message here, 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 and here before it gets sent out. So this is that continued message. If you think about this as like a message, or like a little voice bit, like someone speaking, that is why this is so important. And that is actually it. So thank you for watching, and please continue to watch on, or please continue to work on the assignment below.